So every 2 seconds, somewhere in the world of fraudulent credit card transaction is attempted. Global credit card fraud losses exceed to 33 billion in 2023. So traditional rule-based fraud detection systems such as blocking transaction over a certain amount typically detects only about 60 to 70% of fraudulent detection while generating a high number of false positives. So today I will demonstrate how Amazon SageMaker AI enable us to build a machine learning powered fraud detection system that achieves an AOC ROC score of 98%. So basically, this POC demonstrates like how fraud detection system can be built on AWS using Amazon SageMaker AI. It addresses three major challenges. The speed fraud decision must be made within some millisecond accuracy. The system must be minimize the both false positive and the false negative, and the scalability. Like bank processes millions of transactions every day, so requiring an infrastructure that automatically scales. So for the data, we took 1 lakh synthetic transactions generated with a realistic fraud rate of 1.5%, 2 ML model XGBoost for supervised fraud detection and random cut forward for unsupervised anomaly detection, and Amazon SageMaker, which handles the model training, deployment, and testing. So basically, because real banking transaction data is highly sensitive, this POC uses a synthetic transaction. So each transaction contains 14 important features which include transaction amount, time of transaction, international transaction indicator, distance from customer's home, amount compared to customer average spending, whether device is new, external for the store, etc. So without this SageMaker, building a solution would require manually provision servers, configuring ML environments, and managing Docker containers. So Amazon SageMaker automates these operational tasks, so developer can focus entirely on ML, and with a single call to estimator.script, basically which automatically launches ml.m5.x large instance, download the optimized execute container, reads the training data directly from Amazon S3 bucket, and stream logs out during the training. So XGBoost requires labeled data, so random cut forest is an supervised anomaly detection, which basically it looks what normal transaction behavior looks like and identify unusual transaction uh, without requiring labeling. So for deployment, once the training completes, deployment require only one command, which is estimated.deploy. So the real-time prediction basically consider the following transactions. Like for example, I have created a dashboard for it. So you can see here, this is the fraud detection dashboard for which we are using Amazon SageMaker XGBoost plus random cut forest. So here it displays the total transaction, fraud detected, fraud rate, and amount secured. So the live transaction feed basically in every 1.5 seconds a new transaction appears. Green entries represent legitimate transaction, which is safe. Red represents transaction flagged as fraud. The fraud detection, fraudulent transactions generally involve large amount international merchant unusual time. So fraud probability gauge, this one is basically the risk levels are 0 to 30% safe, 30 to 55 medium, 55 to 70 high, and 75 to 100 basically critical risk. Then we have charts. You can see here the transaction volume chart displays the legitimate versus the fraudulent detection over time. Large distribution is basically show the Caesar imbalance between legitimate and the fraud transaction. Then ROC curve. Basically, this illustrates model performance. The closer the curve is the closer the curve is to the upper left corner, the better the classifier. Then we have the basically the confusion matrix. Confusion matrix is basically it summarizes the model performance. Basically, true negative, true positive, false negative. This demonstrates the trade-off between customer experience fraud prevention. So the basically the model identifies the most influential fraud indicator like external risk score, amount versus average spending ratio, distance from home. You can see here. So you can also use manual prediction. For example, a lot of foreign transaction, like for example, the transaction amount, is this international, the amount, is it a new device, and then you can analyze the transaction. You can see here, it is a safe transaction with the fraud probability this. This is the confidence, and this is the transaction amount. So consider a bank processing 5 minute transaction at a fraud rate of 1.5%. So basically, 75,000 fraud attempts occur daily with a recall of 83.7%, which approximately is 62,000 fraud transactions every day. Assuming an average fraud value of $400, this represents approximately 25 million in fraud prevented daily. Meanwhile, the SageMaker endpoint costs only $200 per month. This results in extremely high return on investment. So basically, to summarize, we built a complete enterprise-grade fraud detection system using Amazon SageMaker AI. The platform trained models without managing infrastructure, deploy them as a real-time REST endpoint within minutes, and achieve an AUC RSS score of 98.1% and provide a scalable production. So this was my previous.